The theory of the water jets experiment, moving fluids in natural or artificial systems may exert force on object in contact with it. To analyze fluid motion, a finite region of the fluid control volume is usually selected, and the coarse effect of the flow, such as its force or choke on an object, is determined by calculating the net mass rate that flow into and out of the control volume. This force can be determined as in solid mechanics by the use of Newton's second law or by the momentum equations. The force exerted by a jet of fluid on a manifold or can be resolved by applying the momentum equation. The study of this force is essential to the study of fluid mechanics and hydraulic momentum. For practical application, we can use for engineer and designer use the momentum equation to accurately calculate the force that moving fluid may exert on a solid body. For example, in hydropower plants, turbines are utilized to generate electricity. Turbines rotate due to force exerted by one or more water jets that are directed tangentially onto the turbine's vanes or pockets. The impact of the water on the vanes generates a torque on wheel, causing it to rotate and to generate electricity. For the objective of this experiment is to investigate the reaction force produced by the change in momentum of a fluid flow when a jet of water strikes to a manifold, and to compare the result for this experiment with the computed forces by applying the momentum equation.
As you can see, the distance of the water travel depends on the height of each holes. You should see that the stream coming out from the topmost hole land the nearest or to the bottle. The further down the hole, the farther its stream lands. This phenomenon is created by the different water pressure at each hole. In this experiment, water pressure is the force applied from the water above onto the water below. Because this force comes from the weight of the water at the bottom receives the most water pressure. High water pressure pushes the water out through the hole the strongest, and therefore the stream shoots the farthest.
Assalamualaikum Doktor, I'm Nurul Shakira. My matrix number CN210160. The conclusion is for experiment 2 is when all three holes were open, air went in the top hole while water poured out of the two bottom holes, while the flow on the lowest hole was stronger than the middle hole. These three situations are a good example for pressure. While only one hole is open, no water can escape out, because if that had happened, then the pressure inside and outside of the water would be uneven and therefore was not allowed, but the pressure applied on the hole by the air outside the bottle. When two holes were open, water was allowed to flow out of the bottle because the top hole allowed air to go in, therefore keeping the pressure even inside and outside of the bottle. And lastly, in this situation with three holes open, air went out of the bottom hole because the air going into the topmost hole and kept the pressure even. And that's it from us. Thank you.